Okay, so now you've heard me lecture about the engaged component. You've watched practical examples of the engaged component in a real class. Let's wrap up this part by doing a little brainstorming. You see, because when you get the lesson plans from us and you open it up to the engaged section of the lesson plan, what you're going to see are suggestions. 2, 3, 4 different ideas of how you could engage your kids. For example, this lesson on geometry and house building. The objective of the lesson is to teach 2D, 3D shapes and analyze and investigate how those shapes are used in building houses and other structures. Eventually, in the investigation, the students will build a house of their own using, everyday materials and objects. Now, how do we engage students prior to this investigation? How do we get their mind on the topic, pull out what vocabulary they know, and start to supplement vocabulary they need to know? All right, suggestion number 1, a story. We're going to give you 3 Little Pigs, a printout version of the storybook, or an animation from YouTube. Use the story to have a little fun with your lower level kids. They know the story, so you can use it to engage with vocabulary they know and discuss concepts of what makes a strong house and a weak house and the shapes of houses to come. Okay, maybe you don't like that idea. Well, then number 2, get your students out of their chair, supervised and chaperoned, of course. Leave the building. Go out to the street. Look around at the houses and the structures around you. Have them pick their favorite and sketch it. Have them count how many squares they see, how many triangles they see. Have them make observations and put these in their journals. Okay, let's say you have a class that hates pork and doesn't like to stand up. Now what do? Well, I ask you, please pause the video or wait until the end of this component and then go to your coursework and write down 1 or 2 suggestions of how you might engage the students for this lesson. Now, I understand that you don't have any empirical evidence of your own of what's good or bad in a STEAM class, but that's okay. There are no bad ideas in brainstorming. Put them down, don't censor yourself, and we'll have a discussion in training about some of the different ideas you come up with. Let's do one more. I love this lesson, ramps and roller coasters. In this one, we're teaching about physics and structural engineering and gravitational force and friction, all sorts of stuff. Now, in this lesson, we give the kids insulation tubing and other materials and a marble. And we ask them to create a roller coaster ramp based on some certain parameters. For example, maybe the older kids have to include a loop-de-loop. Maybe the younger kids have to include an end goal. For example, the marble must fall into a cup. We'll talk about that in the next component. But what I'm concerned with is how do we engage and build curiosity and access prior knowledge with these concepts? Number 1, a video. Pull all your students' chairs up in front of the television, put them in a row, just like a roller coaster, and put on a first-person video, point of view of a roller coaster ride. Have them throw their hands up in the air and move left and move right and simulate the concept of being on a roller coaster. This will put all the ideas in their mind, high energy, high curiosity, get them real excited for the whole lesson. Plus, they can ask questions, and you can ask questions to engage on the vocabulary they'll need. Okay, let's say you don't like that idea. Number 2, and this is one of my favorites because it's so easy for the teacher. Put the materials on the table and say nothing. Say nothing. Remember, this is a student-led lesson. So why does the teacher always have to give instructions? Give them a tube and a marble and let them engage themselves. They should have their journals open, of course. And if they do nothing, maybe you can poke and prod a little bit. Okay, guys, make some observations. Okay, guys, what can you do with that marble and that tube? Now, I know what you're thinking. Wait, but what's the purpose? The purpose is to build curiosity. Get them to start asking you questions. Start the dialogue. And also figure out what they already know about tubes and marbles and gravity and all of these concepts. Okay, I'm going to stop rambling now and ask you to go to your coursework and brainstorm 1 or 2 more strategies that might introduce and engage the kids on the concepts of this lesson.